The ITQAN ADF project operates under a strict operational mandate: manage and maintain all fire and life safety systems across a highly secure multi-zone environment. The geographic footprint of this contract spans 95 distinct site locations. The topography includes everything from high criticality royal and VIP villas to data centers, remote defense camps, and isolated substations. This expanded scope is the result of consolidating the primary ADF master file with the newly added South Land sheets. That aggregation yields the final contract volume: 24,821 active fire and life safety asset line items, every single one requiring planned preventive maintenance. Against this massive expansion in asset volume, the baseline manpower allocation stands at exactly 9 personnel. One of those 9 positions is the project manager. This drops the actual on-the-ground execution capacity to just 8 field technicians. These 8 individuals are expected to carry simultaneous, overlapping operational loads. They must execute routine preventative maintenance, respond to emergency troubleshooting calls, verify asset tags, and complete daily compliance reporting across all 95 locations. Managing 24,000 technical assets with only 8 field technicians triggers a total resource collapse. The math dictates systemic compliance failure. On screen is a horizontal bar chart categorizing the FLS asset register by volume. The first step in rigorous capacity modeling is segregating this raw count to understand workload distribution. The register is dominated by 8,407 individual fire alarm system devices, requiring individual testing. Following closely are 6,083 sprinklers and 2,708 fire extinguishers scattered throughout the properties. Further down the list, we find low-volume but complex specialist systems, including 902 FM200 and clean agent assets demanding specialized handling. The scope also incorporates 933 foam system assets and specialized Ansel Titch and Hood systems located in high-risk zones. Standardizing maintenance time across this entire register is a dangerous oversimplification. A visual check of a standard sprinkler head requires entirely different time allocations than testing and resetting an FM200 control panel. Because the complexity of these assets varies wildly, any baseline capacity calculation must isolate bulk routine checks from highly specialized, time-intensive technical systems. This visual represents a technician's theoretical maximum working capacity, calculated at 26 working days per month, 8 hours per day, yielding a baseline of 208 hours. However, contract planning relies entirely on effective productive time, a metric revealing actionable capacity. Planning for 100% efficiency in a sprawling facility environment is a critical error. Systemic friction constantly erodes time. Technicians face unavoidable access protocols for royal zones, mandatory travel time, toolbox talks, permit approvals, and detailed CMMS reporting that consume measurable portions of every shift. Applying a conservative 75% efficiency modifier accounts for these realities, permanently stripping away 25% of the total available hours. This leaves a final, mathematically sound baseline capacity: 156 effective productive hours per technician. Failing to build this 25% environmental friction into the manpower model guarantees resource starvation before the first maintenance route is even dispatched. We can now map that 156-hour individual capacity against standard industry timeframes for planned preventive maintenance across each asset category. For the bulk items, the monthly requirement accumulates quickly. Fire alarms alone consume 841 routine hours. Sprinklers demand 304 hours, and fire extinguishers require an additional 556 hours, demonstrating how rapidly available capacity is consumed by volume alone. The remaining hours are consumed by specialized systems, pump rooms, high-pressure valves, and fire dampers. The final baseline routine workload requires approximately 3,506 hours every single month just to maintain basic compliance. If we calculate the total output of the current 8 field technicians operating at their 156-hour capacity, the maximum monthly yield is only 1,248 productive hours. We are left looking at 3,506 required hours stacked directly against 1,248 available hours. This catastrophic deficit exists before factoring in a single hour of corrective maintenance, backlog clearance, or emergency troubleshooting calls. The current team is operating at nearly a 300% resource deficit. Under these constraints, completion of the master scope is physically impossible. Dividing the 3,506 required monthly hours by the 156-hour baseline capacity dictates a hard requirement of 22 personnel. Scaling a workforce from 9 to 22 requires structural reorganization. Deploying random technicians indiscriminately across a 95 building list recreates the exact efficiency loss we just modeled out. The solution is specialized deployment. Team A consists of 1 supervisor and 6 technicians, completely isolated to manage the high criticality Royal and VIP zones. Team B is a 5-technician squad engineered purely for high-volume, rapid transit coverage across the camps, security gates, and extensive portable extinguisher networks. Team C assigns 1 supervisor and 5 technicians specifically to absorb the Southland expansion, high-voltage substations, and complex utility rooms. Overlaying these 3 teams is a new management and support tier, staffed with 2 technical leads and a dedicated document controller. This support layer is designed to absorb all CMMS database updates, KPI reporting, and site access bottlenecks. Their primary function is protecting the field technician's 156-hour baseline capacity. This 3-tiered structure directly mitigates environmental friction. By localizing expertise and permanently siloing administrative burdens away from field execution, the output becomes reliable. The current 300% resource deficit actively endangers the facility by forcing technicians to skip critical maintenance cycles. Specific bottlenecks are already forming. FM200 installation testing remains pending in multiple locations, and active fire alarm control panel off conditions sit unaddressed because the 8-man team simply cannot physically reach them. The 22-man structure eliminates the high risk of delayed maintenance and weak emergency readiness, replacing it with dedicated, on-demand troubleshooting capabilities. Furthermore, shifting the administrative load to dedicated document controllers ensures precise asset-level tagging, correct inspection histories, and perfectly reconciled client reporting. This analysis provides a core capacity formula that facility managers must utilize to prevent systemic failure. Total assets, multiplied by specific maintenance times, adjusted aggressively by an access constraint modifier, dictates the absolute minimum required headcount. Data-driven manpower studies are the only mathematical defense against scope creep and the resulting compliance failure. In massive-scale facility management, arbitrary manpower allocation creates operational liability. Rigorous, bottom-up capacity modeling guarantees both audit compliance and true emergency readiness.